Rewrite the quadratic in the form y equals a times x minus h, the quantity squared, plus k. Find the vertex, the range, and graph the function. Again, I would try and complete the square, moving the constant to the other side of the equation. You can leave it on the same side of the equation, but then that involves making sure that you have a positive, then you add a negative to make it go away. So it's just a little bit more confusing if you leave it on the same side. Our second step is to group our x's. Our third step is to factor out the leading coefficient. Now this is factoring out, so you have to make sure that you restate the exact same statement I have here. So when I factor the 2 out of x squared, that leaves me with an x squared. And when I factor 2 out of x, well, 2 times what number would give me x? And that happens to be 1/2 x. Another way of thinking about factoring out is to divide the original by what you factored out. So if I divide x by 2, I get 1/2 x. Our next step is to try and complete the square. So we have our y plus 3 is equal to, and the 2 stays here. The x comes down. The plus sign comes down. And half of this coefficient comes down. And half of a half is a fourth. Now we're going to square that fourth. 1/4 squared is 1/16. And we're going to multiply it by the leading coefficient. 1/16 times 2 is 1/8. So we now have y plus 3 1/8 is equal to 2 times x plus 1/4, the quantity squared. Our last step is to try and get y alone. So y equals, we do that by adding a negative 3 1/8 to the other side. And 3 1/8 could be changed as an improper fraction, 25/8, which is negative. So now we have y equals 2 times x plus 1/4. That quantity is being squared, and we're subtracting 25/8. So in our instructions, they still want the vertex. When you're trying to graph, it's very important that you put in the middle of your table the vertex. The vertex is found by the inside inverse. Inside with x is positive 1/4, so it's negative 1/4. And also the outside number stays the same, negative 25/8. And that's our vertex. So that would go in the middle of our list, negative 1/4, negative 25/8. And they also want the range. And the leading coefficient helps us to determine the range. The range for this graph, since the leading coefficient is positive, will go up to infinity. And it starts at the number all by itself on the outside. It starts at negative 25/8. Now I'm going to try and find numbers on both sides of negative 1/4. Bigger than negative 1/4 would be a positive 0, or actually 0 is not positive or negative, and 1 on the other side. Now on the other side, if I'm not unevenly spaced, if I go to negative 1, the distance between 1/4 and negative 1 is negative 3/4, which is not the same as the distance from negative 1/4 to 0, which is just 1/4. So the numbers on both sides of my graph will not be the same. The parabola will be correct, but the distances aren't the same. So I'm going to put these numbers back into the equation. 0 gives me a negative 3. 1 squared is 1 times 2, plus 1 more is 3, minus 3 is 0. And now when I put in these negative 1 and 2, I will not get these answers because it's not the same distance from the 1/4. So negative 1 squared is positive 1 times 2 is 2, and then I subtract 1, which is 1, and subtract 3 is negative 2. And if I put in negative 2 squared is positive 4 times 2 is 8. 8 subtract 2 is 6. 6 subtract 3 is 3. So you can see these numbers aren't matching up, but let's look at our graph. We're at negative 1/4, negative 25/8, which we saw was negative 3 1/8. So we're about, oops, sorry about that, we're about right there. That's our vertex. And from there we know that we're going to be going up because it's positive. At 0 we're negative 3, so it went up just a little bit on that side. And at negative 1 it's at negative 2, so it's a little bit higher on that side. And at positive 1 it's 0. And at negative 2 it's positive 3. So I think you can pretty much gauge this parabola, nicely smoothed curved shape, and it does pretty much have that symmetry on both sides of this line, x equals -1/4. And so there you have my sketchy little graph of a parabola.